This video is on the objective make a conclusion and interpret the results of a one-mean hypothesis test. Now this is with the population standard deviation unknown, right? So it's a t-test, not a z-test. And this is using the p-value approach, not the critical value approach. Okay. And this is number 2 in this, this objective. So hopefully you've seen the number 1 video, the first one, and this time I'm going to go through this a little more quickly when we look at this question related to this objective in your Newton Alta homework. All right, so let's take a look. Now again, if you're unfamiliar with the topic, want to see more about it, click on More Instruction. Look at their videos, their notes, their examples, and hopefully they help. All right, so here we have Preston, an official for a state's Department of Safety, wants to show that the population mean speed of passenger vehicles traveling on a certain expressway is greater than the posted speed limit of 65 miles per hour. So that's like mu is greater than 65, and that would be you see that's the alternative hypothesis down here. And then the null hypothesis is that mu equals 65, right? That the mean is, the mean speed of passenger vehicles on this highway is equal to 65 miles per hour. Preston collects a random sample of 59 passenger vehicles traveling on the expressway and finds that the sample mean speed is 67.1 miles per hour, with a sample standard deviation of 7.5 miles per hour. All right, and then should Preston reject or fail to reject the null hypothesis given the data below? So we have our hypotheses set up. Again, I've already mentioned that the claim is here that the average speed is greater than 65 miles per hour. The null hypothesis is that the average speed is 65 miles per hour, and you're going to assume this. They gave us a significance level here of 10%, and they're telling us the t-score. All right, well again, let me show you real quickly on the calculator how this would be found. All right, so remember, you take your sample mean, which for this case was 67.1. For this sample of 59 vehicles, their average speed was 67.1 miles per hour. You subtract the population mean, the mean of the means, which is assumed to be 65 here. So that's in parentheses in the numerator. Then divided by, and then in parentheses in the denominator, the standard deviation of sample means, right, for samples of size 59. Well, because sigma is unknown here, I'm using S. I'm using the sample standard deviation, which was 7.5, and dividing this by the square root of the sample size, which was 59. And you're going to see this come up as 2.15, right, which they tell us. See, 2.1507, exactly what they're giving us here. The t-score, the test statistic, is approximately 2.15, and we're talking about t-distribution here with 58 degrees of freedom. Right, remember the sample size -1 for these one population, one sample tests for a mean was the sample size -1. That was the number of degrees of freedom for the student's t-distribution. And then they're telling us that the p-value for this test statistic is between 1% and 2.5%. Now let's actually show that. All right. Now remember, this is a right-tailed test. Right? Mu is greater than some value in the alternative hypothesis. So because it's a right-tailed test, the p-value is just going to be the area to the right of our test statistic, which you can again find on your calculator if you want. Now we're doing area under a t-distribution, so I'm going to that t-CDF. And my test statistic is 2.15, and we're going to the right. Now the area all the way to the right, there is no upper value then, so I'm going to leave some big large number here, 99999 there, and then the degrees of freedom is 58. And this is it. This area, see, 0.017, about 1.7%. That's the p-value of our test statistic, and this statement here on the page on the homework is true, right? The p-value is between 1% and 2.5%. Well, remember what you do with that, right? Then you compare the p-value to the significance level. You compare the p-value to alpha. And if the p-value is less than or equal to alpha, you reject the null hypothesis. You reject that the mean is 65 miles per hour and then lean more toward the alternative. If the p-value is greater than alpha, then you don't reject, or you fail to reject the null hypothesis. So you'd keep the fact that, or you'd keep the statement, support the statement that the mean is 65 miles per hour. All right, well, if the p-value is 0.0178, like we see on my calculator, or if we're just looking here, the p-value is between 1% and 2.5%, that's definitely less. So less than or equal to alpha, right? Alpha is 10%. This is definitely, the p-value is definitely less than that. So in that case, we would reject the null hypothesis. Now be careful. There are two options here with reject the null hypothesis. The reason why we are rejecting the null hypothesis is because the p-value is less than the significance level, or less than or equal to the significance level. That's why, not this first reason. Right? And this doesn't even make sense, saying that 2.15 is less than 0.1. That's not even true anyway. But the reason, whether you reject the null or fail to reject the null in the p-value approach has everything to do with how you compare the p-value to alpha. All right, so I'll submit this. Wonderful. Again, please read through your answer explanations. And I don't think there's a second part to this. No, there is not. And again, hopefully watching this couple videos, and they got a similar question here, hopefully watching these two videos on this kind of question will help you when you go through this on your own, and also looking at the more instruction if you need to, their videos, their notes, their examples. Hopefully that all helps you out when you're working on this on your own. And thank you very much for watching.